Okay, so let's start solving this problem. So if you see the same problem, we solved it by Euler's method, okay, and other different methods. The same problem we are going to solve by Runge-Kutta method. Okay, so this is the given problem. This is the initial condition. If you see, this is the domain, and use RK4 with the step size of 0.5. And this is your formula for fourth order Runge-Kutta method. So there are a lot of different methods by which you can solve this problem. So what I'll be doing is I'll be discussing the tabular method. So the first column that I'm going to take is going to be my TI. Okay, so this is my main formula. So when you talk about your main formula is this, that means you need the value of K1, you need the value of K2, K3 and K4. Once you find out the value of K1, K2, K3 and K4, what you have actually done is you have found out the value of yi plus 1. Also, this function is nothing but fxi yi. Okay, so let's use this. So the first column is going to be ti. My second column is going to be my k1. And basically, what is k1? K1 is nothing but fxi yi. Obviously, I don't need to write it down here because you all know, but it's always handy if you write it down there. Then the next value is going to be k2, and k2 is nothing but fxi, if you see, xi plus half into h. Now if you see, what is the value of h here is 0.5. So half of 0.5 is 0.25. So you can write down plus 0.25 comma yi plus half into h. So half into h is again 0.25. So this is going to be yi plus 0.25 k1. So this is the value of k2. So one thing again that you need to note here is the calculation of k1 will be used in calculation of k2. So it's kind of a recurrence relationship, and the value of k2 will be used in calculation of value of k3. Let's move on to the next column, k3. Then k3 is going to be, then is your k4, k4 is f, h is 0.5 and yi is 0.5 k3. Then once you find out k1, k2, k3, k4, then the next is going to be yi plus 1. So let us first write down the value of ti's. So if you see, the value of ti is, it's starting from 0 to 2 and step size is 0. So the first value is going to be 0 plus h is going to be 0.5. Okay, if you want you can leave some more space in between. 0.5. Then the next is going to be 1. Then the next is going to be 1.5, and then it's going to be 2. Okay, so let's start with this first. Okay, one more thing that I forgot to write down is the value of yi. I'll write it down here. That is also required, yi. So when t is equal to 0, y is equal to 1. Okay, so I can use this pen. Now what you're going to do is substitute the value of ti. Okay, one more thing I did here is, this should be t. Okay, now I think this looks good. So basically this is going to be basically f of x, t is 0 1, so you have to substitute 0 and 1 in your equation f. So I'll write down again, which is so substitute this value in this equation and you will get the answer, and you'll find out that the value of k1 that you're getting is minus 1.1, okay, minus 1.100, but there is no need of writing down there. Okay, so once you have done this, now the next thing what you're going to do here is you are going to substitute the value of ti. So what is the value of ti here? So ti is 0 plus 0.25, ti plus 0.25, so basically that comes out to be 0.25, okay, into comma yi is 1, so this is going to be 1 plus 0.25 into k1. What is k1? Minus 1.1. So if you do that calculation, you'll find out that the value that you're getting is 0.725. So this comes out to be 0.725. So basically you have to substitute 0.25, 0.725 in this equation, and the value that you'll be getting is going to be minus 0.752. Let us move on to the next, k3. So k3 is now ti is 0 plus 0.25 0.25, and yi plus 0.25 into k2. So yi is 1, 0.25 into k2, 1 plus 0.25 into k2. k2 is what? This, minus 0.7522. So if you do that calculation, you will find out the value that you are getting is 0.8120. And once you substitute that value, the value of k3 is going to be minus of 0.84. So substitute the 0.25, 0.8120 in this fx, 0.8424. Now the last evaluation is k4. So again ti is 0 plus 0.5 is 0.5 into yi is 1 plus 0.5 into k3. k3 is minus 0.8424. So if you do this calculation, you'll find out that this value that you are getting is 0.5788, and the value of k4 that you are getting is minus 0.4920. So once you substitute the value of k1, k2, k3 and k4 in this equation, k1, k2, k3, k4, and you'll find out that the value of yi plus 1 that you are getting is 0.6016. So for the next iteration, that 0.61, 0.6016 comes here, and you'll continue the calculation in the similar way. So I'll just write down the values from here. If you do the calculation, you'll find out this is the value of k1, this is the value of k2, this is the value of k3, and this is the value y plus 1 again. So basically what we are interested in, this column, and we have found out the value of this. Okay, I think, and this is the value of y, and we're done here. So this is how you will solve the problem by Runge-Kutta method, fourth order Runge-Kutta method. And if you want to see how the problem looks like, I can show you the image. So this is what you will see. So this dotted line is my analytical solution, and this is my Runge-Kutta fourth order method solution. Okay. So if you increase number of points, I think the resolution is going to increase and it's going to be more accurate. But if you see, it's quite accurate as such. So this is it. Thank you.